Alright, this is Sentential Logic number 10, and in this video I'm jumping right into proofs, and, well, they can either be called proofs or derivations. The book that I think this is best to refer to is which is called the Logic book, and there they call them derivations, so I will call them derivations, but they are proofs, and in SL, which is the system of logic, which I did truth tables in, and I did translations from SL to English and English to SL in. That's pretty much the same system, but it's called SD here because the truth tables, like I've discussed, fire truck, are the truth tables are the semantics. The truth tables are the semantics about truth and meaning. The derivations are the proofs, which I'll be introducing here, are the syntax. Syntax is the logical operators we have to do various different things. And in this system we have 11 rules. I have the first 6 here, and then after I explain these, I'll write the rest of them. These 6 are the first 6 rules, and these are the rules with which you don't have to do sub-derivations for. I have here what a proof or a derivation is supposed to look like. Sometimes this is called a scope line. These things are. Some people don't use scope lines, but I do, and the book does that I read does. These two things are what we would call an assumption. These are our assumptions, and we want to derive something. I'm just trying to kind of lay out what a proof is normally going to look like, or a derivation will look like. We have one or more assumptions that are given to us, and they will say to derive something. And these things in here, this is what is called a sub-derivation. This is a sub-derivation. The sub-derivation rules I will get to after this. And sometimes you have to make further assumptions to get what you want. But typically, you will see a problem kind of mapped out like this. P horseshoe Q, this is a single turnstile, which means that P horseshoe Q ampersand Q horseshoe P is derivable from P horseshoe Q, which means that this is your assumption. You could possibly have 1, 2, 3, or even 4 assumptions, and you're supposed to take your assumption and derive this. So, what you have to derive would be, this is what you want. This is what you have, and that's the way that they typically work. So we have 11 rules, 11 things that we can do inside a proof or inside a derivation. The first 6 are here, which I will explain them. These will become more clear once you actually do a proof. And I'm going to do like 3, 4, maybe 5 videos where I'll probably do in each video like 3 or 4 proofs in each one. They won't be organized, but they'll just be like 4 videos where I'm just going to be doing like different problems, just to kind of illustrate how to do a proof or a derivation. So our first rule is called reiteration, symbolized just as R, because when you do a proof, or you have to, and let's say you want to take this conjunction apart, and you want to just take P, you have to say, if you want to do this, you have to say, why do I have P? And you have to put a rule there. You have to like cite why you can do that. So here, you have to, this is your proof, and off to the side here you have all of your you have all of your rules as to why you can do that. So why can I take P? Because I have to cite my lines too. So why do I have P? Why can I just have P by itself? Because of line 2 of ampersand elimination. And you'll just, you have to cite your rules and your line numbers as to why you can have what you have. So first, line or reiteration. Let's say I want to just give P again, and I could say line 3 reiteration. So basically, when you're citing your rules, these things are what you'll cite as to why you can do that. Reiteration is just you're saying something again. If you have P and you want to cite it down the line again, you can do that by the rule of reiteration. Now, in the system of SL, when you're translating and doing truth tables, you have various operators. You have the tilde, ampersand, wedge, horseshoe, and triple bar. There are rules for introducing and for eliminating each and every one of these rules. So there's 2 rules for that, 2 rules for that, 2 rules for that, 2 rules for that, 2 rules for that. So that makes 10 rules, and plus reiteration makes 11. Okay, now to conjunction elimination, which is ampersand E, which means if I have a conjunction P and Q, I can just I just want P, I can just write P, because whenever I have a conjunction, I can just take it apart and do whatever I want with it. Same with Q. If I just want Q, I can just take Q. It's a pretty easy rule. Conjunction introduction. If I want P and Q, if I have P and Q by themselves, I can do that. However, let's say I just had Q, I can't do that. I have to have both of them cited by themselves somewhere in my proof. Now, disjunction introduction, the wedge. This is what my teacher of logic called the stupidest rule ever, because if you have a letter by itself, you can smack anything on it at all. If you have P and you don't even have to have Q in your proof at all. You do not have to have Q at all, but you have to have one of the. If you have one disjunct, then you can have any disjunct that you want, because it's always true. You know, it's the thing. It is Tuesday, or it is not Tuesday. That sentence is always true. So I could put anything I want onto it. So all I need is just one of my disjuncts, and then I can make a disjunction. This is the stupidest rule ever. And this kind of is difficult in proofs because it's so simple, and it's difficult. It's so simple that's hard to always think about. Conditional elimination. A conditional, of course, is a horseshoe, which means if then. If I have if P then Q, and I have P somewhere, then I can have Q. However, if I don't have P, then I can't have Q, because to get Q, you have to have P. And you would cite lines 1 and 2 of horseshoe elimination. Now, biconditional elimination, or the triple bar, which means if and only if I have P, if and only if Q, and I have P, then I can have Q. If I have P, if and only Q, and I have Q, then I can have P. This one goes both ways, while this one doesn't. Like if I had P horseshoe Q, and then I had Q, I could not have P, because it doesn't work that way. All right, now those are the 6 rules that are the simplest. These are the simplest rules, and you do not have to do a sub derivation for. A sub derivation is basically a derivation inside of a derivation, like that. Okay, so now I'm going to erase these and write down the last ones, the harder rules, which are the subderivation rules. We have conditional intro. I'm just going to say intro, which is horseshoe I, and that goes, I have a derivation, and I have to, if I want P horseshoe Q, I have to assume P, and normally we would do this, assume for horseshoe introduction. Now somewhere along within this, if I have Q, then I can have P horseshoe Q, and that's from lines, let's say these are lines 1, 2, 1, and 2 horseshoe intro. Alright, erase this one. And then the next one is negation. This is the hard one. Negation intro, or tilde I. This is what is called the reductio ad absurdum, or reduction to absurdity. If I assume P, assume this for tilde intro, and I want tilde P. If I have P, but I want tilde P, what you have to assume for that, and you have to have a sub-derivation inside of there. Now within this derivation, you have to get a contradiction. So let's say you have Q, and you have tilde Q. You can have a contradiction of anything inside here. It doesn't have to be P or Q or anything, as long as you have something and then the opposite of it. This is the reductio ad absurdum. So if I can get a contradiction inside of here, then I can have tilde P. Just from lines 1 through 3 tilde intro. Now, negation elimination is very similar, which is tilde E. Make sure the camera's still going. Which is very similar. Let's say I have tilde P, but I want just P. I assume for tilde elimination, and again, as long as I get a contradiction inside of my subderivation, then I can have P from lines 1 through 3 tilde elimination. Now, hopefully that's kind of understood. Now these things do get kind of complicated. The negation ones do. Now I will in later videos explain how these all work through doing actual proofs. But I need to give out all the rules first, the 11 rules that we have, and I believe we've got 2 more. Disjunction introduction, which disjunction. Now this is disjunction elimination. Disjunction intro is very easy, and you have to do nothing to really get that. However, if I have a disjunction, if I have P wedge Q, or just P or Q, and I want to get rid of it, then I have to do something a little bit complicated. Something a little bit complicated. Which, if I have that, then I have to assume for wedge elimination in 2 places, and get something. As long as you get the same thing in both of your subderivation for disjunction elimination, then you can have P or Q. All right, and then final one. Biconditional intro, which is triple bar I. That is just, I assume, for triple bar intro, and through this, if I can get Q, and then I assume Q for triple bar intro, and I can get P. If I can do this, now again, this is sometimes will be more complicated than it looks, but if I can assume for P and get Q, and then assume for Q get P, then I can have P triple bar Q, which is from lines 2, 3, 4. 1, 2, 3, 4, triple bar intro. Okay, now those are the 11 rules for doing proofs or derivations in SD or SL, but it's called the system SD because we're doing derivations, we're doing syntax here. Those are the 11 rules, and we can only do things inside of a derivation if the rule says it. We cannot do anything. We can do nothing other than what those 11 rules say. Okay. We can't. Let's say, for instance, that we have P. If we got P, and let's say we want tilde P, we can't just go. There's something we have to do. We have to do to actually get that. Okay, we can't just say that because that is not a part of the rules. A big thing that people will do is that they'll do things inside of a derivation that that no rule says that you can do. Okay, there's no rule that ever says that. Okay, so we have 11 rules, and those are the only things that we can ever do inside of a proof. Inside of a derivation, those are the only things that we can do, and that's it. So I plan on doing 4 or 5 videos after this, and in each video I will do 4 random problems just to illustrate as to how this is done, and how you would do a proof and how to use these rules, because just giving you the rules doesn't really explain how to use them. So I'll be doing that. So if you think I said something wrong, which I don't think I did because it's pretty simple, please tell me below. Or if you have a question, if you have a question about translating in SL to English or English to SL, or about truth tables, which are of the videos I did in this Sentential logic before this one, definitely comment below, because whenever you comment, I get an email, and if your comment is